So, what is the Serverless Agents runtime? Serverless Agents lets you build event-driven AI agents as Azure Functions. You define the agent's behavior in Markdown, choose what triggers it, and give it tools to take action. Azure Functions handles the execution, identity, scaling, and monitoring. This demo shows an intelligent expense processor. The agent evaluates each request against the appropriate policy and routes it for approval, review, or further investigation. Let's walk through it from start to finish. It begins when a request arrives in an unpredictable format. It can be JSON, raw text, or key value data. The request lands in the processing queue, which triggers an execution of our serverless agent for that expense. The agent scales up and extracts the amount, currency, vendor, and category. It then retrieves the available policy documents from storage, selects the policy that applies, and evaluates the request against its rules. Next, a Python tool routes a decision message to exactly one output queue: approved, review, or flagged. In Azure, the tools authenticate using managed identity, and the function app can scale to 0 when there is no work. The key reason this workflow benefits from an agent is that context matters. The same $450 amount can produce a different decision depending on the category and the applicable policy. Now let's run the app. Before we put anything on the queue, let's look at the three inputs. We have a $450 flight, a $450 monitor, and a $450 client dinner. The amount is the same, but the categories and input formats are different. Before we submit anything, I'll run read_decision.py to check the three output queues. This helper script peeks at each queue without removing any messages. The output queues are empty, so we know any results that appear next came from this run. Now I'll use send_expense.py to write the raw contents of each expense file to the inbound queue. Once the messages land on the queue trigger starts a separate execution of our agent for each one. And because those executions are independent, Azure Functions processes them concurrently. After the agent has finished processing all three requests, I'll run the same read script again to see which output queue received each decision. The flight and monitor are approved because they fall within their category thresholds. The client dinner is sent for review because the meals and entertainment policy requires it. Each decision records the selected policy, destination queue, and a one-sentence reason, making the result easy to audit. Now let's look at the three core pieces of our serverless agent that brings this entire thing together: the event that starts it, the markdown that defines its behavior, and the tools it uses to take action. First, look at how simple it is to create the agent. The trigger is just a few lines of YAML front matter that name the queue and declare the queue trigger. That is all the wiring we need. The runtime reads disk configuration, registers the trigger, and starts a separate agent execution for each message. In Azure, the function app uses managed identity to access the queue, so there are no storage keys, secrets, or credentials in the agent file or application code. There is no handwritten trigger function, polling loop, or orchestration code. Next, the Markdown defines what the agent does. 6 plain language steps tell it to extract the data, select and retrieve the right policy, make a decision, route the result, and respond. The behavior is easy to read, review, and change because it's written as instructions instead of application code. The agent file defines its behavior, while runtime configuration, including the model it uses, lives in the app settings. That means we can change the model without it modifying the agent markdown. Before we look at the tools, let's quickly open one policy. The travel policy keeps the business rules separate from the agent instructions and shows why the $450 flight was approved. Because the agent reads these policies at runtime, the rules can be updated without changing the agent itself. Now let's look at how the agent takes action. The tool definitions are intentionally small. They give the agent clear, focused operations while the shared policy store handles the Blob Storage connection. This keeps the Azure SDK and authentication details in one place. Then the route decision performs the final side effect by validating the destination and writing the results to the correct queue. Just like the trigger, these operations use managed identity in Azure. So that's the application. An event declared in front matter, behavior and policy expressed in readable Markdown, and small Python tools that take deterministic action. Azure Functions handles execution, scaling, identity, and monitoring so you can focus on what the agent should do instead of the infrastructure around it. It looks simple because it is simple, and that's the whole point. To help you get started, we've included links to the sample, the quick start, the documentation, and our announcement blog. Everything you need to build your first serverless agent is right here. We can't wait to see what you build. Thanks for watching.